Okay, here are the notes on the next unit that we're going to start, which is called logarithms. So take notes in your notebooks, right? Keep doing that. Log them in. Okay, logarithms. Logarithms are something that you haven't seen, but they're connected to exponents and what we've been just finishing, working on this unit on exponents, rational exponents and all that. Okay, so the first thing I want you to, notes. This is the notes for worksheet 1. Okay. First thing I want you to make sure and that you understand are important facts is about, right? We know we're familiar with exponential form. Something like, right, an exponential form. So you already know this form. We've been working with this form. You're familiar with exponential form. You have something like an example. You know that 4 to the power of 2, right? That means 4 times 4, well, that's 16. Notice that there's a base, an exponent, an equal sign, and then the value over here, right? So we're going to be using the same, 1, 2, 3, or with the equal sign is 4, the same kind of 4 parts when we work with logarithms. But right now we're just going over exponents. So you know that 5 to the power of 3 would be 5 times 5 times 5. And when you do that on the calculator, you know that that answer is 125, right? That's the answer here. That's the answer here. Okay, but here's the new ones. Well, not really new, but just these are the two that students really sometimes get confused. Okay, I'm going to go with 3 to the power of 1 and 3 to the power of 0. All right. We've seen positive exponents, we've seen negative exponents, but we haven't seen 0. Oh, I should put some negative exponents. Here, anything just to the power of 1 is just 1, 3. There's just 3, doesn't really multiply to another 3 to another 3. It's just 1, 3. So that means the answer is just 3. There's just 1, 3. If it was 3 squared, it'll be 3 times 3, it'll be 9, because you have 2 of them. You're multiplying 2 3s. But if it's just to the power of 1, that means you have 1, 3. Okay? If it's to the power of 2, that's 3 times 3, that's 9, and then so on. But what about to the power of 0? The answer is not 0. I mean, here, if it's 1, I got 1, 3. If I got nothing, that means I don't have any 3s. But believe it or not, anything to the power of 0, the answer is 1. Because you could say 1 is everywhere, right? 16 is 1 times 16. 125 is like a 1 times 125. 3 is 1 times 3. But any number to the power of 0, you don't have this number, but it's like 1 times 3, but there's no 3's, right? There's none. So very important. This one's a little tricky. You don't see it much. Let me just review a couple of examples we did with negative exponents. How about 2 to the negative 3? Well, remember, we have to have this, convert this to a positive. So that was 2 to the negative 3. You put a 1 under it. And remember, you have to move the exponent and the base and move it down. Remember that? And then this really, when you move everything from the top down, well, it comes over here. And then what's left up here? Again, you don't put a 0, you put a 1. And if you remember, this is eventually, while the 1 stays on top, And then 2 times 2 times 2 is 8. Okay, so just reviewing a little bit of bases and exponents, exponential form, right? Exponential form. 3 to the power of 1 is telling you there's 1 3. 3 to the power of 0, there's no 3's, there's no number, whatever this number is. But the answer is not 0, it's 1. And then we've already reviewed and covered negative exponents. Okay, let me start on logarithms. This new stuff on logarithms is simply saying the same thing in this new language of logarithms. Okay, so we're going to convert, right? The directions are actually going to say rewrite each equation, right? Because they are equations, because it has an equal sign. Rewrite each equation in logarithmic form. So you're going from exponential, it's going to be given an exponential form, and you're going to convert it into logarithmic form. And this is the form that you're not familiar with. You are familiar with exponential form. Okay, let's go. Number 1, they're going to give you a true statement. You don't have to prove it. You don't have to solve it. It's already true. 8 squared is equal to 64. You're just writing this in another language, like in another form, but you're still saying the same thing, right? Like when you say a word in Spanish and it sounds one way and you say it in English, maybe it sounds similar or different, but they mean the same thing. This is exponential form. Okay, this is exponential form, right? Because of the exponent. Right? All of this is an exponential form. Now we're going to convert it into logarithmic form, right? We're going to need a base, we're going to need a power or exponent, and then the value. This is the way you say the same thing in logarithmic form. You're going to have a log, the base, like a basement, goes in the bottom, the base. Then the value goes here. Equals, right? Because it has an equal sign, so don't forget it has the equal sign. And then another number here. And you're using these same numbers, it's just the way it's arranged that looks off. Because see, you're familiar with this, you're not familiar with this. Okay, so here goes the base. This little one is the base, so what's the base here? 8 to the power of 2. So 8 goes here. The power of 2 does not go here. The power of 2 goes over here. The power is like this big important thing here, right? The power is like the main thing you're trying to figure out, right? 8 to the power of 2, and the 64 is here. So this is how you write 8 squared equals 64 in exponential form, but in logarithmic form it would be log little 8 down there like that, 64 equals 2. Right? Now I'm going to show you a little trick right now so that you know that you did it right. You can check, you can read this and go like this. You're gonna look at this and right, because if you were to put the 2 here and the 8 here or something different, it's not going to work. You can check this if you read this counterclockwise. Starting with the base, counterclockwise, if I remember, clockwise is the way the clock runs this way. Counterclockwise is like to the left. If I start with the base, see, it'll say 8 to the power of 2. And then when you go do the arrow, equals, and then 64. And if that's a true statement, you wrote it correctly. You see? So check by going what? Counterclockwise. Counterclockwise. If I can write this, if I look at this counterclockwise and it reads back this, you did it right. Okay, let's do another one. Number 2. 19 squared is equal to 361. You don't have to prove it. It's true. You can check it if you want on your calculator. 19 times 19 is 361. This is obviously an exponential form. How do you write it in this new form, logarithmic form? Well, there's a number that goes down here, the base. There's a number that goes up here, kind of same level, equals, and then another number that goes here. Remember that? So it's going to have an equal sign, just like it has an equal sign. And then these 3 numbers have to be placed correctly here. So remember, this one's the base. This one's the value or the answer, right? And this one's the most important part, the equal part. The answer is the exponent, the power. So your answer for this in logarithmic form to say the same thing would be what? Log, the base is what? 19 goes down here. The value goes here, 361. The power or the exponent goes here. Okay? And remember, how can you check and make sure? Because it kind of looks weird. It doesn't look the way you're used to seeing it this way. You can go counterclockwise and check. 19 to the power of 2 equals 361. Right? You can go counterclockwise to check. If you would have put the 2 here and the 19 here, 2 to the power of 19 does not give you the same answer. Okay? So that's it. You're just rewriting it from one form to the other form. Okay, number 3. Let's do a couple more a little quicker now. I think you're getting the hang of it. Number 3. 13 to the power of 1. Oh, we just talked about this. Let's just do number 3 and 4 here. I know what 13 to the power of 1 is. 13 to the power of 1 is 13. And what if I do 7 to the power of 0? Well, remember I just talked about that earlier? 13 to the power of 1, there's only one 13. 7 to the power of 0, you can't put any 7s. There's no 7s. The answer is never going to be 0. So what's the answer when the power is a 0? Is 1. Okay, so these will be given to you. The exponential form and all that, that's going to be given to you. Your job is to write this in logarithmic form. Okay, so that's going to be log what? The base is 13. The power goes over here. 1 is equal to 13. So it's like this. And again, you can check it by going counterclockwise. 13 to the power of 1. Does that give you 13? Yes. Remember, starting here with the base. 13 to the power of 1 gives me 13, and it should read the same thing there. Number 4. Log, right? Log is short for logarithm. What's the base here? The base is 7. The power is the answer, right? The power is what it equals, so that's 7 to the power of 0 equals, and then so that means the 1 goes here. Okay? Okay, 2 more for this first part. Number 5. 14. Now remember, we also had negative exponents. Again, you don't have to check this. This is already a true statement. 14 to the power of negative 2 is 196. You're just writing it, right? This is obviously exponential form. You're writing it in logarithmic form. That would be log of what? I need a number here as the base. I need a value and then a number over here. So that's going to be the base 14 to the power of negative 2, right? If I'm thinking this like counterclockwise, is 1 over 196. This is how you write it. 14 to the power of negative 2 is equal to 196. This is how you write it in logarithmic form. So that's all you're doing today. Well, actually, there's more, but This is what you need to understand. Okay, last one. 361 to the power of 1/2 equals 19. Again, you don't have to prove it or anything. It's already a true statement. It's an exponential form. Your job is just to rewrite it in this new logarithmic form. What's the base? This one. What's the exponent? This one. What's the value of this one? Log. Base. Base goes where? Down here, bottom, basement. 361. The answer is the exponent. And the 19 has to go here. Okay, that's going to be the first part for the first 6 problems, just writing them from this form to this form. And you're going to see on the next video, it's going to be much quicker. Okay? All right, good luck with that part.